Good morning everyone. Welcome to day 2. This is DPP2 for MYP and this is on pendulum motion. Okay, so now let us read the first question. This is for 1 mark. Regular repeated motion can be described as periodic motion. Select the image and does not show the periodic motion. For example, the earth here goes around the sun in 1 full year. Okay, and every year it does the same mundane task. It doesn't do anything else beyond it, right? So therefore, this is a periodic motion. I'll represent this by P. Now, what about the clock's hands over here? Now, let us look at the bigger hand over here. So what does it do? So this goes full round 1 hour. Okay, to start from here, it goes round for 1 full time. Okay, and comes back to this. Okay, so therefore, this is also periodic in motion. And what about the basketball that I am throwing here? So definitely it is not periodic motion. Okay, when I throw it from here, I can either throw it from here, it falls down, and then I have to go here, then dribble it, and then once again throw it from here. So this will be a non-periodic motion. Now what's the next one? I think my photo is being blocking this. Just a moment. The swing. The person who is now in a swing. So this keeps on oscillating up and down like a pendulum. So therefore, definitely this is also a periodic motion. So therefore, the correct answer is C. Okay. Now, so it says 1B video link. This one over here. Let me show you the video. I already downloaded the video. So this is the video. Let me play this video in the exam also. You will be required to play this video to understand what it is. During each swing of a pendulum, total energy is conserved. The media is interactive, and note down what's happening over here. This point is A, this point is B, this point is C, and it takes a time of 2.5 seconds. Okay, let me replay it once again. See, starts from here, goes to one extreme, and comes back to this point. It takes a 2.5 seconds to complete one full oscillation. What is that? That's nothing but your time period. Anything else we need to note? Let me check it out once again. So, comes back to 2.5 seconds. Angle is not given, ABC are given. Okay. Now let me go back to this one. Now, select the option that describes the kinetic energy and speed of the pendulum at positions A and B, A, B and C. So how was it now like? So this was the pivoted point. This was your point A. This was your point B. And this was your point C. Now this is a drop down menu. One has to select the drop down menu to select what is the right one. At position A, what was the kinetic energy? The particle was at rest. When it is rest, what do you mean by kinetic energy? Kinetic energy is given by the formula half mv square. M is positive, but v is 0 here, right? The kinetic energy at this point would become 0 because velocity is 0. So therefore, this is velocity is equal to 0. You should have dropped down this one and selected the 0 here. This would be 0. And then at position B, what was the kinetic energy? When it came down here, the speed starts increasing here. When it was at this point, the speed was very, very high. So therefore, when speed is higher, v square is also higher. V is high, v square is higher. The kinetic energy will be maximum. This would be maximum. And position C, kinetic energy, what will happen? Once again, the particle comes over here, its speed is higher, and when it goes like this, what happens? The speed keeps on reducing. When it goes to this point, the speed becomes completely 0. Because it has speed is equal to 0, it once again turns back like that, right? So therefore, here also the kinetic energy is 0. Now let us look at potential energy. Now what we do is, let me assume that this line is the reference line. So therefore, when the particle goes upwards at point A, it is at a height h. It's at a height h over here. So the potential energy is really higher, right? It's very, very high. So I can now say that this is maximum over here. Position B. At position B, what's the height? Height h is equal to 0. So this height, right? This height is the origin. H is equal to 0. So therefore, potential energy should be 0 here. And then at position C, once again, this is seen to be maximum. Okay. And then the next one, speed. Now what do we do for speed? We'll write down the same thing that's over here. Okay. So because we inferred kinetic energy only based on speed, so I can just say this is 0, this is max, and this is 0. Now the misconception which the students usually do it here is that they will consider when the height is going in this direction. For example, along the negative x-axis, they might consider as negative because here instead of 0, the option given here is not 0, but it is a minimum and maximum. If it was given as minimum, now the problem arises over here. So what they will think is this is going on the negative x. Actually, locate the coordinates properly. Okay, so therefore anything that you measure in this direction is positive and everything that you measure in this direction is seen to be negative. So definitely when the particle is in this side or in this side, the height is always positive and therefore the potential energy is also positive. Okay, remember this. Okay, let me move on to the next one. The pendulum can be used to determine the acceleration due to gravity g. The period t of the pendulum is the time taken to complete one full swing. That's what we have seen. T depends on the length of the pendulum, L and G. T is given by the formula. The value of G varies with location of the pendulum, and a pendulum is used in a laboratory in Canada has a length of 72.5 centimeters. Okay, the value of L is given to you. Value of L is given to you, and the time taken for 10 periods is seen to be 17.1 seconds. So 10 periods. That means what? I do not immediately stop there. It keeps on going once, twice, thrice, and so on. So it has taken 17.1 seconds for 10 such oscillations, right? So therefore, I can now write 10 time periods is equal to 17.1. One time period is equal to 1.71 seconds, right? By unitary method, I divided this by 10. So I get this value over here. Okay, and then calculate the acceleration due to gravity in G in the laboratory, giving your answer to 3 significant figures. You need to calculate this value of G. How do you calculate the value of G? See, from here, the value of T is known to you. 4 pi square is a constant. Pi is 3.14. L value is also given here. L value is given. We just need to substitute all of them, get the answer. That's it. Very simple. So therefore, what I will do is, I will write this as 1.71 square is equal to 4 pi square multiplied by, what is the value of L? L is 72.5 centimeter, which is 0.725 centimeter divided by G, right? So therefore, I'll get the value of G is equal to 4 into 3.14 square into 0.725 divided by, I'll push this one downwards, 1.71 square. Okay, so when I do this and I need to calculate it using this, so how do I calculate? I'll use my calculator. You can also use your GDC or Decimas to do this. Let me take up my calculator. Right. So this will now give me 4 into 3.14 into 3.14 multiplied by 0.725 divided by 1.71. Did I do the calculations properly? Yes, it's right. Okay, so divided by divided by 1.71 because it's twice, right? I do this once again, I get 9.778. So I get this as 9.778, which is 4 significant figures. I'll make it as 3. Right? This is 9.78 meters per second square. This is what I have got here. Okay, and now what I will do is, what's the next question? The expected value of acceleration due to gravity is 9.82. Suggest why the experimental value in part C is different. What is the reason? Okay, how do we know this? So what we need to do is, let me read the question once again. So what does it say? There is one important clue here. Why is this clue given here? Value of G varies with location on the Earth's surface. Where is Canada? Okay, is Canada? See, the Earth is something like a spherical. That's what we say, it's spherical. But strictly speaking, it is not spherical because you know, this is the axis, this is the equator. Okay, and if you do not know where is Canada, then what you do is, see, equator is a position where it is very, very hot. Canada cannot lie over here because Canada is a cold country, so it should lie somewhere over here. So what happens is, so if it is here, then this could be your radius. See, one important misconception students have it. If I say Canada is here or maybe Canada is here, okay, R is the radius over here. Okay, so therefore the radius, we assume the radius is same. But actually, since the ball starts rotating, for example, you take some object, let us say you take a dough, a floor for example, wheat flour for example, make it as a dough, and then what you do is, or maybe clay also, then you start rotating it, okay, with some speed. And what happens? If you are rotating with respect to an axis, the one which is nearby to the axis will have an oblate, will be something like an ellipsoid like thing, but this one will now start shrinking. So therefore, as you see, let me just take it down. So as you see here, the value of G varies with location on the Earth's surface, which means at different positions the what you call the acceleration due to gravity will be different. Definitely Canada is not at the equator. Okay, it's somewhere far away over here. The radius that you have over here is totally different as compared to this radius over here. Okay, so that's why we say at the equator it could be something, but here it will be much higher or much lower. It could change over here, right? So now let me read through the question. What does it say? So because of the altitude, so expected value of acceleration due to gravity at this location is 9.82, but we got an experimental value in part C to be different. What is the reason for it? Because you know the altitudes at different countries vary, and hence radii of Earth is also different. You can mention this. This is one mark over here. You can mention this, or maybe you can say Earth is not spherical complete. It's not completely spherical. But somewhere this seems to be oblique. Okay. Now let me move on to the next question. So the next question says, a wrecking ball is an example of a pendulum that can be used to demolish buildings. It's a very heavy steel ball hanging from a crane which is released and swung to hit the structure. Okay, so you have something like a wrecking ball and you want to destroy this building. What you do is you take this ball, you hit it across, it goes and hits here, and then it breaks off this building. Okay, so you see the initial height of the ball is 12.5 meter and it hits at a height of 4.5 meter. Okay, and then what next? Initially the ball is stationary. The crane operator releases the ball to the height of 12.5 meters. Good. Calculate the kinetic energy of the ball when it hits the building at 4.5 meters above the ground. Totally, you see, the whole problem is only about simple pendulum. Okay, that's why he has changed it in a different way. Now he is asking you to find out what is the kinetic energy at this point. He is asking kinetic energy of the ball when it hits the building at 4.5. What is the kinetic energy? So what happens over here? Why should it gain kinetic energy? Because you know we have taken this ball all the way along to this height, and at this height the potential energy is seen to be mg into h, right? Potential energy is equal to mgh. What is this value? Now first let me find out what is the mass of this ball over here. So I can very clearly say that is what it is. A wrecking ball is an example of a pendulum. It is very heavy steel ball. Mass is not given over here. It's given here. Mass of the steel ball is 2000 kgs. So how do I calculate the potential energy here? I just need to substitute the value, which will be 2000 multiplied by the value of G. What's the value of G is taken? Don't just assume 9.8 or 10. It depends on what is he giving over here. Wrecking ball is an example. Okay. Now, is it given anywhere? It is given here 9.81. So take this value 9.81 multiplied by what is the height? 12.5. Let us calculate what is this value so that you will be able to write correctly what is the value of the kinetic energy. Potential energy here, then I'll tell you what is kinetic energy. So this should now be 2000 multiplied by 9.81 multiplied by 12.5, right? 12.5. Enter this, you get 2,45,250. So you get 2,45,250. What's the unit? Joules. Okay, energy is joules. Or maybe I can write 245 kilojoules. 245.3 kilojoules. Since it's 3 significant figures are required, so I can just put it as 245 kilojoules. Okay, and now what is being given here? He says give you a result to rounded to 2 significant figures. Oh my god, I don't even want 3. So it means this would be rounded back to 250 kilojoules. So the answer is 250 kilojoules. This is potential energy. Now where is the kinetic energy? The kinetic energy here is nothing but, see, the potential energy, all the potential energy over here has got converted into kinetic energy over here, right? And hence, ignoring air resistance, what we can say is that the entire potential energy is what is the kinetic energy. This is nothing but your conservation of energy, right? Potential energy becomes 0 and all the potential energy is taken over from here. Okay, now the potential energy is 250 kilojoules. Now, Now this energy is taken by this bob, okay, or the steel ball to come all the way along here. Now what is the energy at this point? The energy at this point is potential energy B plus kinetic energy B. See, many of you will make a mistake saying that the entire potential energy has got converted into kinetic energy, which is incorrect. Okay, so therefore see to it that the potential energy is got converted into this potential energy is get converted into potential energy B plus kinetic energy B. So in other words, according to conservation of energy, I will write like this. Okay, so I will now write, first let me simplify, then I will put it into significant figures. I will write this as 245, 250, and this one would be, what is the mass here? 2000, right? 2000 multiplied by 9.81 multiplied by 4.5 plus kinetic energy. This is what I can get. In fact, many of you might be thinking, I can just subtract 12.5 minus 4.5. You can do that. Okay, nothing wrong. You'll be able to do that. It's the next step, but anyway, I'm doing it like this. This should now be equal to 245, 250 minus, let us compute what is this value here. There is my calculator once again. Take this value and I'll write 2000 multiplied by 9.81 multiplied by 4.5 will give me 88,290. Right, it is 88,290, which would now be equal to 245. Let me do this once again. 245, 250 minus 88,290 will give me 1,56,960. 1,56,960. So I can round this off and write this as equal to 157,000 joules, which should now be equal to 157 kilojoules. This should be your answer. This should be your answer. Okay, because he asked you only about kinetic energy, he is not asking you the total energy. Remember this, okay, and don't write this is equal to 250 kilojoules, okay, which would be incorrect. Okay, now next, let me move on to the next one. Now the next question states, calculate the real world kinetic energy of the wrecking ball. Suggest why the real world kinetic energy of the wrecking ball would be lower than the calculated value. Why should it be lesser? What could be the reason? You know, this ball, while it is swinging from that height to this height, definitely it is having something like friction. Sorry, not friction, the air resistance, right? There will be a wind resistance over it. So therefore, some amount of energy would have been lost over there, and as a result of it, you will lose it. Now, this is for 1 mark, and you need to write something here. What is that you are going to write? You are going to write the total energy of the ball is expended in terms of potential energy plus kinetic energy plus energy required to overcome the wind resistance, and as a result of it, some energy is lost. Hence, some energy is lost, and therefore kinetic energy of B will be less than the kinetic energy B calculated. Okay, though it is 1 mark, but definitely you need to mention about all these things. Okay. Now let me move on to the next. Okay, so I think we have come to an end to this particular paper, and in the next video we will continue with the next question. This was a question on criterion. Okay.